Bismillahirrahmanirrahim. We are still speaking about the angles. In the last part, we defined the angle as it is the shape or the area formed by intersecting of two lines. And we said that we have different types of angles. First one, we call the acute, when the measurement of the angle is less than 90. And when it is equal to 90 degrees, we say it is right angle. And if it is more than 90, then we call it as obtuse, and when it is equal to 180, we name it as straight angle. And then we defined the complement and supplement angles. And we said that two angles are complement if their sum equal to 90 degrees. These are complement angles. And if their sum is equal to 180, then we call this supplement angles. And also we said that for the angles, we can measure it in the positive direction or negative direction. We have for any angle, as we said last time, we have initial side and terminal side. If the measurement from the initial toward the terminal counterclockwise, we say this is positive angle. And if it is in the counterclockwise, if it is a clockwise direction, we call it negative angle. So we have positive and we have negative. And also we said that if we have angle where the initial side is on the positive x-axis and the vertex of the angle is at the origin, then we call this is an angle in the standard position. We call this a standard position. Standard position. That's what we have discussed last time. Now for today, we are going to define something called the coterminal angle. The coterminal angles are two angles have the same terminal side. So start the definition. Two angles are said to be coterminal if they have the same terminal side. Or we can say that if they are in the standard position and have the same terminal side, means that if I have this angle, suppose that we have this angle with measurement 30. This is the terminal side. If we move one complete circle and come back again, then I have 30 and 300 or 30 plus complete, which is 360. That will give me 390. We said that the 390 and 30 are coterminal angles. If we move one more, then I will add another 360. That will give me 750. Then 3 or 30 and 750, we say that they are coterminal angles. So the coterminal angles are two angles having the same terminal side. same terminal side. To clarify this, let's take some examples. With that, we have this given angle there. Find, or let's say determine the measurement or the measure of the positive angle less than 360. So I need this condition that is less than 360 degree. That is coterminal with the given angle. Number one. So with that, I have this angle theta equal to 745 degrees. And I need to find the smallest positive coterminal angles. The easiest way to find the positive coterminal angle is that to subtract 360 from this one. Since I have positive, this is theta equal to positive 745. To find the coterminal, because we have rule for the coterminal, it is theta plus k 360. This is the rule for to find the coterminal, where k is positive if, sorry, k is negative integer number if theta is positive. If theta is given positive, we are choosing k negative number. And if theta is negative, we'll choose k to be positive. And k is positive if theta is less than 0, or theta is measured with negative measurements. Now, since I have theta equal to 745, k is integer number, can be 1 or minus 1, minus 2, minus 3. So for theta equal to 745, I would say the easiest and simplest way to find the coterminal angle. I will say 745 minus 360. Just subtract 745 minus 360. I can use the old way. I will have, this will be 5, 14, it will be 8, and this is 6, will be 385. But 385 is not less than 360. We said that I need to be less than 360. Now, since this is not less than 360, I will go one more step. Again, I will subtract 365 or 60 again. And I will have 25 degree. So 25 degree is my coterminal angle. It is the smallest positive angle that less than 360. So I can say that 25 and 745 have the same terminal side. So the coterminal angle will be this one. This is the coterminal angle. This is a classical way to find the coterminal angle. There's another way is to divide 745 by 360. It will be 2 point something. I will take the integer number k equal to -2 and use it to find the coterminal. But this is easier than dividing the given angle by 360. Let's have another one. Number 2. But that you are given theta equal to 1060, for example. And I want to find the coterminal. As we did, as first step, I'm going to subtract 360 is minus 360. This is 0, 0. This will be 10, 3. This will be 760. But 760 is more than 360, which means I need to go one more step. I will subtract from this one again is 360. I will have 0, 0, 4. Again, 400 is greater than 360. So I need to go one more time. Minus 360, I will have 40. So the 40 is my coterminal angle. I can say theta prime or double prime as coterminal is equal to 40 degree or 40 degrees. So this is the coterminal angle. To this one, 1060. One more, number 3. Some of that theta is given by minus 480. Now theta is negative this time. We have to be careful about this one. Since we have negative, in this case, I will add. I'm not going to subtract 360. I'm going to add this one to 360. Let's add. It is like we are subtracting now. Minus 480 plus 360. This will give me minus. This is 0 will be 2, 1. This is 120 or minus 120. If we have or adding two numbers with negative or different signs, we are taking the sign of the maximum absolute value. That will be minus 180. I will get minus 120. But minus 120 still is a negative number. It is not positive. And in my question, I said, find the smallest positive coterminal. This is not positive. It means I have to add one more time. So add one more time to 360. It will be 240. Now 240 is positive and less than 360, and that will be the coterminal. This is the coterminal angle. I can say theta double dash or 1 dash is equal to 240 is my coterminal angle. This is the coterminal angle. One more. Theta equal to 240. One more, number 4. theta equal to minus, let's say, 750. Again, to find the coterminal for this one, I'm going to add, because this is negative sign. If it is negative, I will add. So to find the coterminal, I will say this will be plus 360. I will have 0, 15 minus 6 is 9, and 4 or 6 times minus 3 will give me 3. So it is 390. But negative sign. This is minus 390. But this is negative. So I have to add one more because I need to find the positive. This will give me minus 30. Still, it is negative. So I have to add one more. It will be plus 360. It will be 3 or plus 330. So the coterminal in this case will be 330 degrees. This is how to find the coterminal angle. Why do we need to find the coterminal? Because later on we will find the trigonometric function sine or cosine, tangent, cotangent for some angles that are larger or bigger than 360. And in that case, we have to find something called the reference angle or the coterminal angle to evaluate the trigonometric functions. One more step or one more point in this section, it is the convergence of the degrees and radians. For the measuring the angles, we have two measurements. It can be measured with degrees or it can be measured with radian. Sometimes we need to convert between radian and degrees. So this will be the radian degree conversion. To convert from degree to radian, we multiply by degree to radian pi over 180. The reverse from radian to degree we multiplied by 180 over pi. This is how to convert between the degrees to radians or from radians to degrees. For example, convert to radian. Number one, for that I have theta equal to 45 degrees. Now to convert it from degrees to radian, I'm going to multiply by pi over 180. Because this one, if we just make it like logical process, this degrees will cancel with the degrees down. So I'll have only one unit, which that will be radian up, because this is radian over degrees. This is degrees, and this is degrees. This degree will cancel with the degrees. I will have only the radian. So to convert from degree to radian, I will divide or multiply by pi over 180. Now, if we simplify 45, this will give me 45 pi divided by 180. Now, 45 and 180 can be simplified. This will give me pi over 4 radian. It is pi over 4. So 45 degrees is equal to pi over 4 radians. Another one. Number 2. With that I have theta equal to 210 degrees. Again, multiply by pi over 180 degrees. This, if we simplify 210 with 180, this will give me 7 pi over 6. I can divide by 3 up, 3 down. I will have 7 pi over 6 radian. So 210 equal to 7 pi over 6 radian. Now, if we reverse the process, suppose that I will need to convert from radian to degree. Degrees. Number 1. What I have, let's say, theta equal to 2 pi over 3 radian. And I need to convert it to degrees. To convert it to degrees, I'm going to multiply by 180 over pi. So this pi will cancel with this pi. Now 180 divided by 3 is equal to 60. This is equal to 120 degrees. It is 120 degrees. Last example, number 2. Theta equal to, let's say, 5 pi over 4. And I want to convert it to degree. Again, it is 180 divided by pi, multiplied by 180 divided by pi. So this pi will cancel this pi. And simplify, I can divide 180 with 4 equal to 45 multiplied by 5, it will be 225 degrees. So 5 pi over 4 equal to 225 degrees. So this is the idea of how to convert from radian to degrees or from degrees to radians.